Hi everyone, this is the notes for 4-7, all about our points of concurrency. A blank copy of this notes sheet is in your Google Classroom, but we'll go through each of our different special segments, and then we're going to add a little bit on today and talk about some different points. Let's start with our medians. For our median, this is a segment that connects our vertex to the midpoint of the opposite side. So the first thing I'm going to do on my pictures here, notice we have 3 different triangles. So we're covering all of our bases, and we're talking about all of our different options and different scenarios that can happen. And on each of these, I'm going to start by finding the midpoint. So I'm going to find the midpoint, but I'm going to really, again, emphasize that this is the midpoint by showing you that it is. I don't know anything about this triangle, so I don't know that the 3 sides are congruent, even though they look like they could be. But I'm going to just draw my 3 midpoints. Then, to draw my medians, I'm going to connect a vertex down to the midpoint on the opposite side. And I'm going to draw this vertex over to this midpoint. And I'm going to draw this vertex over to this midpoint. And notice when you do this, I didn't even draw this perfectly. I didn't pull out my ruler. I didn't measure, but I did a pretty good job. And if I had measured, they would all match even more exactly to a point in the middle. All 3 medians meet. Let's do it on the other 2 triangles as well, and then we'll look at them. So I'll draw my midpoint. I'll draw my midpoint. I'll draw my midpoint here. And then I'm going to connect my vertices to the corresponding midpoint. And when I do this, again, they meet at a point here, if I drew it perfectly. And then again, for my obtuse triangle, I'll do my best to estimate where those midpoints are. If we were in class in a typical year, I might pull out rulers and have you measure, and you could measure. Whoops, that one's not very good. And it would work out fairly nicely. All right, so what's happening in all of these pictures? Again, kind of pretending like my picture is perfect and looks nice and I measured and everything. Well, all of these meet at a point, and that point has a special name. I'm going to kind of fudge that obtuse one a little. This point is called the centroid. And this point is a special point, and most of our points of concurrency today are going to tell us something that it does in the picture. Notice on all 3 examples here, our centroid is always inside our triangle. Now, this centroid actually is the center of gravity. And I mean literally the center of gravity. If we were to have a cardboard triangle cut out, and I measured my sides, and I drew my medians, and I found the centroid, and I put my finger on the centroid, that is where that cardboard triangle, or any triangle, right? You could make it out of anything. That's where it would balance. This also does something else, though. The centroid here, it creates a 2-to-1 ratio on the median. And so what do I mean by that? I mean, I cut this median into 2 parts and then into 1 part. The 2 parts are always from your vertice to your centroid, and the 1 part is from the centroid to the side. And this is along all of the medians that are drawn in all 3 different situations. All right, our altitude is next. Altitude is my favorite one to draw, but it actually doesn't make any, the point has a special name, but it doesn't really make a special point. But altitude, I'm going to think about dropping down. So I'm going to move my triangle and move my paper around so that this is the floor, say, and I'm going to start up here at this vertice, and I'm going to drop down to the floor. And if you watch the homework video, our shortest distance down is always perpendicular, And so there, I'm going to mark off that when I drop down to make that altitude, it was perpendicular. And when I do this from all three, again, it's not perfect here, but pretend like I drew it nice and perfect. They do, all three altitudes meet in a point. A little different things happen for these other two triangles though, so let's see. First, this is going to be my floor. So when I drop down from up here, I'm just going to drop straight down. I already have a right triangle, and so there we go. I'm going to turn my picture, and this is going to be the floor now. And I'm going to drop down, and there we go. There's my altitude from that right bottom vertice. I'm now going to turn around so that this hypotenuse is my floor, like literally the floor. And I'm going to drop down, and when I drop down, I get something about like that. And again, these all three do in fact meet. The obtuse triangle, I think, is the hardest one to see. So my floor, well, let's start out with this being the floor. And here I am up at my point, and I'm going to drop down to the floor. It's okay that it's outside the triangle here, but I'm going to really extend too, because you'll see after what's going to happen. So I'm going to drop down, and I'm going to pretend like I drew it perfectly, and I'm perpendicular to the floor there. All right, this time I'm going to turn my triangle, and it's hard. I can't do it on the video for you, but that new line that I just drew is going to be my floor. I'm going to be up at this point right here. I'm going to drop down to the floor. When I drop down to the floor, I am perpendicular to the floor, and there is my altitude. For my last one, that hypotenuse is going to be the floor, and I'm going to drop down to the floor, and I'm going to be like this, except I really want to extend that out. So, oh, that's not very good. I'm going to, let's see if I can do this. I'm going to extend out. Ooh, I did not do a very good job drawing my perpendicular. Pretend like you didn't see that. Okay. So there's my altitude. Oh my goodness, what is going on here? Pretend like I didn't totally bungle up my diagram and that is actually perpendicular there. We'll pretend it is. Again, all of these points meet, all of these altitudes meet in a point. But where is that point? Well, it can be in my triangle, it can be on my triangle, or it can be outside of my original triangle. This point is called the orthocenter. You are going to need to know these names and which they match up with, like which special line of concurrency they match up with. So add them on to your flashcards. The orthocenter doesn't tell us anything special. Excuse me. It just tells us it's where the altitudes meet.